Hi guys, welcome back again to my YouTube channel. For today's video, we will talk about the application of the differential equation, which is the population growth rate problems or yung population dynamics. So meaning, the population changes corresponding to time. So as we can see, if we will review the law of growth and decay problem, the rate at which the substance changes is proportional to the quantity of substance present at any time. So if we will analyze this question, we can solve that by using this kind of equation. So for the growth rate problems, we have the dp over dt is equals to kp, where dp over dt is the rate of change of the population, p is the number of inhabitants at any times or size of the population, and k is the constant of proportionality. So from the given module na binigay ko sa inyo, nandun po yung solution how we can get this PT. This PT is equals to PO over times E raised to KT. So meaning we can use this as our pag magsosolve tayo ng isang equation. So for us to get those equations, so we can use again this the general solution for the growth rate problems. So this one we can denote this one as the rate problems. Okay, so from ulitin ko lang uli yung solution. How do we get this one is you can based on my sa module na binigay sa inyo. Okay? So, I will give you some example for today. So, kung mababasa nyo dun sa example na binigay ko dun, hindi ko na siya sinulat ito kasi sobrang haba. For example number 1, a team of biologists performed an experiment to determine the effectiveness of chemical to accelerate the growth of a specific bacterium. They introduced 40 bacterial colonies into a growth medium, and exactly 2 hours later the number of colonies has grown to 200. In fact, the number of colonies for the first 5 hours of the experiment. Calculate the number of colonies that were present 5 hours after the experiment began. So we can denote this one as let P is the population at any time, meaning 5 hours after the experiment began. Okay, so we can use the formula. Itong formula na to. So when okay, so when T is equals to 0, our population at the time 0, or it is equal to ano ba nakalagay doon? 40. So meaning ito daw yung bilang ng bacteria before yung unang number ng bacteria nilagay dun sa colony. So we must first get the P sub O or meaning the initial P in using this formula. So P of T is equal to P O E raised to K T. Okay, so our P for this one is 40. This equals to P O E raised to, ang K natin dito is we're looking for K. So, we're looking for A. So, ang hinahanapan natin dito is P sub O. So, ang T natin is 0. So, this one is 0 times K is 1. 0 times K is 0. Any number raised to 0 is equals to 1. So, our P sub O is equals to 4T. Okay, so meron na tayong value ni P sub O, which is the population at the initial, that is the initial population. Okay, so when T is equals to 2, sabi kasi dito, 2 hours later the number of colonies has grown to 200. So from this equation, we can get the value of T. So our P for this one is 200. Okay? So by using this formula, so P of T is equals to P sub O E raised to K T. Our P T at a certain time, our P at 2 hours after, so times 40 E raised to K times 2. So 200 divided 40 is 5, is equals to E raised to 2K. So looking for the value of K, we can solve this by a calculator. So we can get the value of K as K is equals to 0.805. Okay, so from these values, we can now get the value of the number of colonies were present 5 hours after the experiment began. So again, so when T is with the time is 5 hours after the experiment began, so we're looking for the value of P. So from this one, using again this formula, so gamit na gamit po siya, E raised to KT. So this one is, it is equal to, ang P sub O natin is 4T. So E, ang K natin is 0.805 times the time is 5. So 40 E raised to 4.025, or it is equals to 2,236 number of bacterium in the colony. So meaning 2,236 daw yung naging increase niya 5 hours after the experiment began. Okay? Okay, for example number 2, excuse me. So, yung problems again, ang problem again nandun sa binigay kong module, I will read na lang siya dito sa aking video tutorial. So, the population of the Earth was 3.5 billion in 1970 and was increasing at a rate of 2% per year. What is the rate when will the population of the Earth reaches to 50 billion? So, ang question here, what is the time or the year na ma-reach natin yung 50 billion? 50 billion number of population. So, as you can see, we have here is 2%. So, I think ito yung proportionality constant. So, meaning kasi, ang sabi kasi dito, increasing at the rate of 2% per year. Ibig sabihin, kung titingnan natin, kada year daw, 2% of 2% yung inaangat. So, first of all, we can let the value of K is equals to 2% per year. Okay? So, kasi ito nga yung sabi natin proportionality constant. Okay po? So, yung P natin dito, it is yung population at any time t. Okay? So, for the solution, we can use the formula kanina. So, when t is equals to 0, the year 1970, the number of population daw is 3.5 billion. So, using this formula, so P sub O e raised to KT, so, or P from the initial value or the P for the time for the year 1970 is 3.5 billion. So, it is equal to P sub O e raised to K times 0. So this one is always equal to 1 because any number raised to 0 or any variable raised to 0 is always equal to 1. So our P sub O is equals to 3.5 billion. So ang question here is what is the time na ma-reach natin yung 50 billion. So when T is equals to, that is the required, P is equals to 50 billion. So, by using this formula, P sub O e raised to KT, our P sub T here is 50. This equals to, ang P sub O natin is 3.5. E raised to, ang K natin is 2%. So, 0.02 times the time. So 50 over 3.5 is equals to E raised to 0.02 T, or by using the calculator or the solve for X, we can get the value of T as 133 years. Okay? For the final answer, we cannot use this one kasi we're starting from 1970. So, if we will use this answer na 133 years, mangyari na mamamali tayo kasi para bumalik tayo dun sa nakaraan. So, for the, since it was after 1970, the time is equals to 1970 plus 133. It is equal to 2103 years. Okay, meaning the year 2103. Okay? So I think that's all for today. So I hope you guys understand the law of the growth problems or the population dynamic. So thank you guys, and see you sa next topic natin, which is the topic number 8. So for the bonus part, so our first digits are 3.14. Okay, thank you. Hi guys, welcome back again to my YouTube channel. Yo. So for today's video, we will talk about the radioactive decay problems or the decay problems itself. So meaning this kind of a problem is almost the same with the population growth rate problems kasi as in sobrang wala silang pinagkaiba. Nag-iba lang ng letters na ginagamit. So again, for the general solution to get the value of this one, o paano natin siya napapunta dito, you can gamitin ninyong pagbasehan yung ginawa ko lecture manual. Okay? So, for the decay problems, we can denote this one as the dq over dt is equals to k times q, where the dq over dt is equals to rate of change of the substance, P is the amount of substance present at any time, and K is the constant of proportionality. Okay? So, yung definition ng radioactive decay problems, nasa manual naman yan. So, we can now proceed for the example. So, for example number 1, we have here is, hindi ko na siya sinulat ito, basahin ko na lang siya. Okay? So, a radioactive materials decays at a rate proportional to its amount, meaning is equal daw. So if the material has a half-life of 30 minutes, what percent of the original mass is expected to remain after 0.8 hour? Okay? So hinahanap is the percentage of the original mass after 0.8 hour. Okay? So for example number 1, so we can now let the value of Q, so let Q is equal to mass of the radioactive material at time t. Okay? So, sabi daw dito, a radioactive material decays at a rate proportional to its amount. So, meaning, so the initial value here is when T is equals to 0, Q is equals to Q sub O. Okay? So, depende siya dun sa conditions na binibigay dun sa equation. Okay? So, when T is equals to 0.5, kasi sabi niya dito, if the material has a half-life of 30 minutes, so if we convert it into hour, so it will become 0.5. So, nung 30 minutes daw, magkakaroon siya ng half-life. So, meaning, Q is equals to 0.5 Q sub O. Okay? So, for the solution, Q sub T is equal to Q sub O e raised to K T. Okay? So, 0.5 Q sub O is equals to Q sub O e raised to K times 0. So, from here, wait lang. So, 0.5 pala to. Okay? So, cancel tong Q sub O. So, 0.5 is equals to E raised to 0.5 K. Okay? So, by using the calculator, we can now get the value of K, which is the value of K is negative 1.39. So from this equation, from this answer, now we can get the value of the original mass, the percentage of the original mass remains after 0.8 hour. So, nung oras daw na yon, which is the time is 0.8 hour, so what is the mass? Okay? So, using this formula, Q sub O e raised to KT, so Q respect to time is equals to the Q sub O itself, kasi sabi na naman nila parehas lang daw sila, so E, so hinalap lang kasi dito is percentage. The K is negative 1.39 times 0.8. So from this equation, we can now get the value, the percentage, which is the 0.33 Q sub O. So meaning, this is 33%. Ibig sabihin, 33% daw yung natira after 8 hour. Okay? So, this, now, this is our final answer. Ibig sabihin, 30% of the Q sub O. Okay? Okay, for example number 2, so basahin na lang na ulit natin. You can use as reference dun sa aking module na binigay. So, a hazardous material was found to decay at a rate proportional to the amount present. Initially, there were 50 mg of the radioactive material that was present. Okay? After 2 hours, it has lost 10% of its original amount. Find the mass of the material after 4 hours. The question now here is the mass after 4 hours. So for example number 2, we can now let the value of Q as the mass of the material at time t. Okay, so from the initial time, when time is 0, our Q is 50 mg. As sabi, initially there were 50 mg of this radioactive material. Okay, so for the solution, we can use this formula. Q sub O is equals to E raised to KT. Our Q sub T here is 50 E. Okay, for example number 2, you can use my lecture module as a reference for the example number 2. So I will read the example here. Hindi ko na siya sunod kasi sobrang haba niya. Diba? So, for example number 2, a hazardous material was found to decay at a rate proportional to the amount present. Initially, there were 50 mg of this radioactive material that was present. Okay, so after 2 hours, it has lost 10% of its original amount. Find the mass of the material after 4 hours. Okay, so for example number 2, we can use the formula given, which is the Q of T. Q of T is equals to Q sub O E raised to KT. So for example number 2, we can now let the value of Q as the mass of the material at time t. Okay, so for the solution, when t is equals to 0, meaning that our Q here is 50. So, using the formula of Q of T is equals to Q sub O E raised to KT, so our Q here will be 50 is equals to Q sub O E raised to K times 0. Any number or any variable raised to 0 is always equal to 1. So our Q sub O here is 50. Now, after 2 hours now, it has lost 10% of its original amount. So, when T is equals to 2, our Q is 10% of 50 is 5. So, 50 minus 5 is 45 mg. Okay? So, by using again this formula, Q sub O E raised to KT, our Q here is 45. Our Q sub O is 50. And then our K here is, we're looking for the value of K. And the time is 2. Okay? So 45 over 50 is equals to E raised to 2K. So by using the calculator or solve the value of X, so the value of K here will be negative 0.053. So now we have the value of the Q sub O and the value of K. Okay, so the question now here is find the mass of the material after 4 hours. So when T is equals to 4, we're now looking for the value of Q. So Q of T with respect to time, or when it comes after 4 hours, so Q sub O E raised to KT. Okay, so our Q sub O here is 50. Our K is negative 0.053 times the time is 4. So our final answer here will be 40.5 mg. Meaning, after 4 hours, the mass of the material is 40.5 mg. Okay? So, I think that's all for this topic. So, I hope you all got some knowledge or learnings from this video tutorial. So, for the bonus type of bonus question, bonus pinag-usapan natin. So, I will denote this one as the digit 2 and 8. Okay? So, once again, thank you guys for watching. And don't forget to like, subscribe, and share. Thank you so much. Bye.